Here is an explanation for the answer to final exam question number 27 in Physics Demystified, 2nd edition. Please refer to page 518 and 519 if you have the printed book. We're talking about a semiconductor diode with forward bias. We apply a direct current voltage in such a way as to produce what we call forward bias. That means that the anode is positive with respect to the cathode. And if we apply a sufficient voltage to this semiconductor diode to overcome the forward breakover, what will happen? Well, the forward breakover voltage of a diode is a silicon diode is somewhere on the order of a half a volt. So we need to have at least a half a volt of forward bias in order to overcome the forward breakover. If we do that, we will get a continuous flow of current through this device. So the correct choice is A. An interesting little addition to this video. Let's suppose that the bias that we apply to a voltage is graphed on the horizontal axis of a graph, and then the current flow forward and reverse is graphed on the vertical axis of the same graph. I'm trying to stay within the confines of the camera range here to not go off the beige board on you. So that's the voltage and that's the current. We'll call voltage E, current I. So this is forward bias and that's reverse bias. A typical silicon diode will start out no current up until we get to the forward breakover point. Then we'll see an abrupt increase in current, which increases as we continue to increase the forward voltage up to a certain point where we'll saturate the diode or blow it out. If we reverse bias the diode, we'll get no current until we reach another point considerably greater than the forward breakover. That's called the avalanche point. And then we'll get a sudden dramatic increase in current. But our question here is asking us what happens if we operate a diode in this range right here. We'll get a continuous flow of current. Again, the correct choice is A.